The audio control panels are used to manage the radio and interphone communication systems for transmitting and receiving audio. In addition, navigation receiver audio can also be monitored. To transmit audio, you'll use one of the microphones shown here. To receive audio, you'll use a headset or the flight deck speakers. The captain, first officer, and first observer audio control panels are installed on the aft aisle stand. Each panel is equipped with transmit and receive selectors. You can select any number of receive selectors on at the same time, but only one transmitter selector can be selected at a time. When a receive select switch is on, the green light illuminates and the audio volume may be adjusted by rotation of the selector. If you're listening over the flight deck speakers, the audio volume can be further adjusted by the speaker volume control. To turn the flight deck speaker on or off, push the selector. With the speaker turned on, rotate the selector to adjust the speaker volume. Now note, the observer audio control panel does not have this feature. Pushing the receive switch a second time turns off the associated green light and turns off the receiver, unless the associated transmitter selector is on. The transmitter selectors are used to select a radio for transmission. When selected on, the mic legend illuminates, the transmitter is available, and the associated receiver is automatically turned on, regardless of the position of the receive selector. To transmit over a radio, push the desired transmitter selector and then key a microphone. The handheld mic is keyed by the use of the push-to-talk switch. If you're wearing a headset or oxygen mask, you can key the mic using switches shown here. We'll now describe the mic interphone switch in detail. The normal spring-loaded position of this switch is the center off position. Pressing the mic position keys the boom microphone or oxygen mask to transmit, as selected, on the audio control panel. Pressing the interphone position keys the boom microphone or oxygen mask on the flight interphone. Each audio control panel is equipped with a VOR ADF receiver selector. The four positions of this switch allow the pilot to select the associated VOR or ADF radio for audio monitoring. Each audio control panel has an approach receiver selector. The four positions of this switch allow the pilot to monitor the audio for the 3 ILS radios or the marker beacon. The approach left, approach center, or approach right positions monitor the respective ILS radio, and the marker position monitors the marker beacon audio. The navigation filter selector is used to filter VOR, ADF, ILS, or DME audio. In the V or voice position, only the voice audio can be heard. In the B or both position, both the voice and range audio can be heard. In the R range position, range audio, navigation aid Morse code identifier, can be heard. Note, marker beacon audio and DME identifier are available in all positions. Finally, the audio control panel is equipped with call lights. An illuminated call light indicates a call on cell call, the flight interphone, the cabin interphone, or SATCOM. The call light will reset when the respective transmitter select switch is pushed, or, if already pushed, by pressing a mic interphone switch. However, the SATCOM call light remains illuminated until the call ends. Note, the PA does not have a call light. Now, let's answer those questions.
There are 3 interphone systems: flight interphone, cabin interphone, and service interphone.
The flight interphone provides a means for the cockpit crew to communicate with each other without intrusion. Now, this system comes in handy when the boom mics are in use, or more importantly, when the oxygen masks have been donned. During aircraft pushback, the ground personnel can communicate with the cockpit crew using the FIS. This is accomplished by plugging into a jack at the APU ground control panel on the nose wheel strut. The cabin interphone system allows for communication between the cockpit crew and the cabin crew stations. Handsets in the cockpit and in the cabin are normally used for the CIS system. However, the cockpit crew can connect the FIS to the CIS by use of the interphone switch on the ASP and the flight interphone switch on the pilot's call panel. This allows the cockpit crew to communicate with the attendants using the handheld mics, the boom mics, or even the oxygen mask mics in conjunction with a headset or the cockpit speakers. The CIS is a party line system. Any person that picks up a handset is connected to the line. Therefore, for security reasons, care should be taken as to which person may be on the line during communications. Now, this frame shows the cockpit call lights and provides a description of each light. An illuminated light indicates the station that is calling the cockpit. You should know that these lights also function as switches and can activate a call to the selected station. Therefore, the cockpit crew can initiate calls through the pilot call panel or the pilot handset. Calls to a specific flight attendant station are made by pushing the appropriate button. Likewise, the attendants have a call system that can call any other attendant station or the cockpit. An alert button is installed at each station. This button will call all other cabin stations and the cockpit. The station that originated the call will not receive the alert. A series of 3 high-low chimes will activate when an alert button is pressed. Now, persons on the ground can call the cockpit using the call button on the APU ground control panel. Likewise, the cockpit crew can call ground personnel by sounding a horn in the nose wheel well.
The left and right VHF communication radio control panels are located on the aft electronic panel. Each control panel is used to tune the communication frequency for the respective radio.
There are 2 frequency indicator windows on each panel. one window is selected as the active window, which makes the other window inactive. Selection is made by use of the transfer switch. The active window is indicated by the illumination of the associated control light. Dual-level knobs are used to select a frequency for the respective window above the knobs. The outer select knob selects the 3 left digits of the window, while the inner select knob is used to select the 2 right digits. Some aircraft are equipped with a COM test switch. Push this switch to remove the automatic squelch and permit reception of background noise to verify the VHF receiver operation. We now show a different panel that is installed on one aircraft in our fleet. This panel has a voice data switch and a data light. Each press of the voice data switch causes the radio to switch from voice to data mode or vice versa. The data light illuminates when the radio is in the data mode. Next, to answer some questions. High-frequency HF radios provide long-range communication between the aircraft and a ground station or between aircraft. There is only one antenna for both HF radios. It is located inside the leading edge of the vertical stabilizer. Both radios may receive at the same time. However, if one radio is transmitting, the other radio is cut out from operation. The off position removes power from the unit. The frequency is selected by 2 selector knobs. Rotation of the left knob changes the digits to the left of the decimal point. Rotation of the right knob changes the digits to the right of the decimal point. The USB position, upper sideband, allows the radio to transmit and receive on the high side of the frequency. The AM position, amplitude modulation, allows the radio to transmit and receive on the selected frequency, but the radio signal is accompanied by a carrier wave. The antenna must be tuned before transmitting. The antenna is automatically tuned after a frequency change is selected, when the pilot presses the push-to-talk switch on the microphone. Press the mic key to begin the antenna tuning process. The antenna tuning process may take from several seconds to a full minute. A tone will be heard through the cockpit speakers or through the headset while the antenna is tuning. When the tone stops, normal communication is available. There are 2 different HF panels in our fleet. The panel on the left has an RF sense knob, and the panel on the right has a squelch knob. The operation of these knobs is identical. Please read the pop-up description of these control knobs. The cockpit voice recorder has 4 recording channels to record audio conversation from various microphones. It is powered whenever normal AC power is applied to the aircraft. The recording tape is a perpetual tape that is overwritten by new recordings every 30 minutes. Thus, recordings of up to 30 minutes are available, and earlier audio is automatically erased. A control panel is installed on the forward overhead panel. There are different panels on our fleet as shown here. Both panels are equipped with a microphone, 2 push buttons, and a headset or headphone jack. On this frame we show the top panel has a status light, and the lower panel has a monitor. The area microphone on the face of the voice recorder control panel records to one of the 4 channels. All audible cockpit conversations are recorded through this mic. The monitor indicator has a pointer that deflects to confirm the recording or erase process of all 4 channels. The pointer rises into the green band when the test button is pushed. The test button is pressed to sound a tone that may be heard through the headset that is plugged into the headset or headphone jack. For the panel with a status light, the light will momentarily illuminate after a successful test. For the panel with the monitor indicator, during the test, the monitor indicator pointer will rise into the green band. The erase button is pressed to erase the entire tape. It only operates on the ground when the parking brake is set. Press the button for 2 seconds to activate the bulk erase on all 4 channels. The pointer momentarily deflects during this erase.
Well, the FARs require that the airline dispatcher and flight crews are able to communicate at any time. This allows the dispatcher to alert the crew of required route changes or other changes in the flight, while also allowing the crew to call system control and receive a phone patch to any department. ACARS is an acronym for Aircraft Communications Addressing and Reporting System. Airlines can subscribe to the ACARS system to provide a communication network to their aircraft from anywhere throughout the country. A network of ACARS transceivers is installed around the country so that an aircraft is in range from any position. The ACARS system allows system control to call a specific aircraft at all times and allows a crew the ability to tune the number 3 VHF radio for voice communications through a phone patch. A list of frequencies is provided that shows the ACARS frequency you need to use for the position of your aircraft. Now, there are 3 ways to operate this system depending on the equipment installed on the aircraft. The fleet is equipped with ACARS as described in paragraph number 3 on this frame. In addition to voice communications, ACARS provides data communications between the aircraft and the Flight Operations Department. ACARS reports certain flight information automatically. An example would be the reporting of out, off, on, and in times. The pilots can also send messages manually using ACARS. The crew can uplink messages from the company. This includes AccuLoad and flight plan information, in addition to other features.
Here you can see where the ACARS components are located on a typical installation. The management unit, or MU, is the heart of the system, located in the E&E compartment. The interface between the ACARS MU and the pilot is now incorporated into the CDU. The ACARS is also equipped with a printer to provide the crew a hard copy of received information. The Multipurpose Interactive Display Unit, MIDU, works as an interface to the ACARS system. So, how does it work? The ACARS management unit on your aircraft normally sends and receives messages in data format through the VHF, HF, or SATCOM. The ground stations relay messages to the ACARS Center in Annapolis, Maryland. The ACARS Center sorts these messages and delivers them to the appropriate airline. The messages are routed through system control.
Now you've learned that the ACARS MU normally transmits and receives data through the number 3 VHF radio. Therefore, the MU tunes the appropriate frequency and transfers data messages without input from the crew. With the installation of the new generation ACARS, you'll be surprised at how many additional useful features are now available. Future considerations may include the ability to communicate with ATC over the ACARS to relieve the congestion that occurs with multiple voice transmissions at certain airports.